In this video, we're going to be covering another interview question. This question is actually question number 163 in Leetcode. The question has been, it's a locked question. You need a subscription in order to see the question. Okay, so the problem statement is that given a sorted integer array where the range of elements are 0 to 99 inclusive, return its missing ranges. So this is also kind of a scheduling question, like we want to know what ranges are available and which ones are not available. So as an example, if you have been given this sorted integer array, and again they said that the range of elements are gonna stay between 0 to 99, which it is, and then again the limit has been given. The lower limit is 0 and the upper limit is 99, so I guess the limit can change. Okay, so we're gonna be given the lower limit, the upper limit, and we're gonna be going through the sorted integer array and looking for the numbers or the ranges, the missing ranges, and putting them into an array and returning the result. So if I'm here, right, basically I should start, so the first thing I want to do is like compare this with the lower. If there is any difference, I'm going to be creating either just a number or this range string. In this case I don't need to do it because 0 is already in there. Then I'm gonna go 1 and process 1 and the 0. There is no difference, so I'm gonna keep going until I find out that I and I minus 1 has a difference. In that case, I'm gonna be putting, again depending on how much is the difference, I'm gonna be putting in either the number or sending it to a helper function which is gonna convert the numbers into this kind of range. Again, when I'm here and I see that sitting here, I see that 49, 4 to 49 is missing, so I'm gonna putting that into a string and so on and so forth. And at the end, when I'm done with it, I still need to compare the upper limit with this one. So yeah, that's what we're gonna be doing. So let's say public list of string, find missing ranges, int nums, int lower, int upper. Okay, then first thing we can have a result list of string is equal to new array list. Once we have that, the first thing is that what if the nums is null or the nums dot length is equal to 0. In that case, what we're gonna be doing is like we still need to have this upper and because even if this is null or there is no element in this one, we still need to create that lower arrow and then upper string. So for that one, we're gonna be writing down this function output to result lower, upper, and the result, and return the result. At this point I would like to actually implement that function. It's much easier to actually visualize this function in this scenario where nums is completely, there is nothing in the nums. So void output, it's void because we're gonna be filling up the result. We don't want to return anything specific, we're just gonna put things into result. Start and end and the list of string inside the result. So the first thing is that we're gonna be creating a string buffer, sb equal to new new string buffer, and then if the start is equal to n, in that case we just need that number, so sb dot append that start number, right? Otherwise we want to create that arrow thing, sb dot append start plus arrow plus end, and in the end we want to add that thing to this result dot add sb dot to string. Nice. Okay, yeah, that would be our function. So now we're gonna continue doing our processing. The first thing we wanted to do is like if the nums of 0 minus lower is greater than 0, we're gonna say that we're gonna call this function output to result. Again, the starting point would be lower and nums of 0 and nums of 0 minus 1, and that's the result. Then we're gonna do the same thing at the end for the last element. So if the upper, right, minus nums of nums dot length minus 1 is greater than 0, we're gonna say that the output to result is nums of nums dot length minus 1. That would be the that's where we're gonna start from, plus 1, and then the upper result. And you can see the similarities between this conditional and this condition. So we want to make sure that if the lower is actually less than the first element, we need to process that, and if the upper is actually bigger than the last element, we need to process that one too. Now the last thing is that we need to process all the things in the middle, right? For that we're gonna say that int I equals to 1, I is less than nums dot length minus 1, I plus plus. So if the nums of I minus nums of I minus 1 greater than 1, so remember this one, we only need to process when there is some difference. It is more than, like, the difference between the current element and the previous element is more than 1, and that's the only time we want to process it. Output to result. Again, we're going to start with the lower number, plus 1. Nums of I minus 1, and the result. That would be at the end of this one. We can just return the result. In terms of the complexities, let's just talk about that for a second. Okay, so when we are here, right? Basically, if this is the length of the nums is n, we are going through that, and we are going through that in a linear format, and then that is basically in a linear format, and so it's going to be linear. The time complexity is definitely linear. We're not doing anything other than iterating through this, the elements of the nums. So O of n would be the time complexity, n being the number of elements in the nums. In terms of the space complexity, that would I would say, because we are saving everything and we are going to be saving based on the elements on the nums, we're going to be just it's also going to be linear, and this is because we have to store the results into a separate uh, list of string, so that's why we need some space for that, and that's going to be linear too. Yeah, often for both time complexity and the space complexity. That's all I wanted to cover. Thanks for watching.